Hello, Abby. How are you doing?
Hi, sir. I'm good, thank you. How are you?
Very good, very good. So today, what do you want to do?
I was wondering if we go through some like questions regarding like the topic of the trigonometry addition formula and like the double angle formula as well.
Okay, so compound
Um,
angle formulas in trigonometry.
that one. Yeah.
I am Anil Kumar. Welcome to my series on trigonometry. As per the request of my student, Amy, I'll discuss few questions related to addition formula. You may take this as an assignment. In case you want to learn from me, you can always send an email on the address given. Also visit our website globalmathinstitute.com for the latest updates. Now, this assignment will have four questions. You can see three of them right now. I would like you to pause the video, copy these questions, answer, and then look into my suggestions. The very first one is to show that tan of 45 degrees plus theta is 1 plus tan theta over 1 minus tan theta. Related to that is hence obtain the exact value of tan 105. Question 2. Show that sine alpha plus beta equals to 2 sine alpha cos beta, and part B is express 2 sine 8x cos 2x in the form of sine A plus B plus sine B. Question 3a. Solve the equation 2 sine x plus pi by 3 equals to sine x plus square root 3 cos x. Show that 2 sine x plus pi by 3 equals to cos x plus pi by 6 can be written in the form 2 tan x plus square root 3 equals to 0. So based on this, we have more questions. So normally you see that these questions are so designed that one part leads to the other. Question 3c is hence solve the equation 2 sine x plus pi by 3 equals to cos x plus pi by 6, where x is between 0 to 2 pi. Note 0 and 2 pi are not in the domain. So at times the student might do that kind of a mistake. Question 4a. Show that the equation cos x plus 5 pi by 6 equals to sin x can be written in the form cos x plus square root 3 sin x equals to 0. Hence solve the equation cos x plus 5 pi by x equals to sin x, where x is between 0 to 2 pi. Now these are the questions which are normally asked in UK examinations, mainly Edexcel type. So, if you are in UK or doing a similar course, you will be very familiar with these types of questions, where a question, different parts lead to the solution. However, in North America, we will be asking you direct questions, right? So, here's a key difference. However, in these questions, you understand you have a better understanding of the methodology to follow, and that will help you to understand the topic better and answer such questions. I hope it makes sense. Take this as an assignment. I'll provide you with part solutions and some hints in this particular video. Now, before getting into details, let me remind you of the standard formula which we refer to as compound angle formula. So, as you know, Sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. Cos A plus B is cos A cos B minus sin A sin B. Cos A minus B is cos A cos B plus cos A sin B. Now, from these formulae, you can actually derive the double angle formula as mentioned here. Now, that could be a part of your exercise. Another very important question is to derive the formula for product to sum. So these are the formulae for product to sum which can be directly derived from compound angle formulae. You can treat this also as an assignment. Another important set of questions is to write these compound angle formulae from sum to product. So we say sine alpha plus cos beta is equal to what? Well, that is equal to 2 times sine alpha plus beta over 2 times cos alpha minus beta over 2. Similarly, we could derive the formula for sine alpha minus sine beta, cos alpha plus cos beta, and cos alpha minus cos beta. Now these are very important formulas. You should practice derivation of these. So derivation of these formulas is in addition to the assignment which I am sharing with you at present. However, these are sometimes taken as test questions. So I hope you are almost ready for answering all these questions with basically the compound angle formulae which are listed here. So we are going to use these formulae extensively to answer all the questions mentioned in the beginning. Let's begin with the very first one, which is show that tan 45 plus theta equals to 1 plus tan theta over 1 minus tan theta. So I did not share with you the tan formula. Let me write that down now. So if I have tan A plus B, in that case it is equal to tan A plus tan B divided by 1 minus tan A tan B. Now since we want to find what is tan of 45 degrees plus theta, we can substitute A as 45 degrees. So we get tan of 45 degrees plus tan theta over 1 minus tan of 45 degrees times tan theta. Now what is tan 45 degrees? As you know, tan of 45 degrees is 1, and therefore this can be written as tan of 45 degrees plus theta is basically equal to, since tan of 45 is 1, we can say it is 1 plus tan theta over 1 minus tan theta. So that is how we prove part A. Straightforward, right from the formula. Now let us see, how do we do or find the exact value of tan 105? Well, you can take tan 105 as what? Tan of 90 plus 45? That will not work. Then what? Well, 105 is, if I take away 45, what do I get? Well, I get 60, right? So I could write tan of 105 as 45 plus 60 degrees. So basically, I know that that should be equal to 1 plus tan theta over 1 minus tan theta. So I only need to find what is tan 60. So for that, we can use the right angle special triangle. As you know, for 60 degrees, tan value is what? Well, that's your triangle. Tan of 60 is square root 3. So we can substitute tan 60 as square root 3 and then find the answer, correct? So I can write tan of 105 degrees as equal to tan of 45 degrees plus 60 degrees. And since I know this is 1 plus tan 60 over 1 minus tan 60, I can substitute the value, which is 1 plus square root 3 over 1 minus square root 3 to get the answer. Now, most of the time, it is important to rationalize this, correct? And therefore, I'll recommend you to rationalize and then write down the answer. So, the key here is to rationalize. So, the students should multiply and divide by the conjugate of the denominator, which is 1 plus square root 3. You get the idea. So, once you rationalize, you get what? Well, the numerator now will be perfect square, which is 1 plus square root 3 whole square, which can be written as 1 plus 2 square root 3 plus 3. And the denominator will be a square minus b square, that is 1 minus 3. Correct? And therefore, you get the answer, which is 4 plus 2 square root 3 over 1 minus this is minus 2. You can now divide by minus 2 and write down your answer. You get the idea. So the answer here will be what? 2, which is a negative sign, 2 minus square root 3. Do you get it? So that becomes the exact value for tan 105. You can see that it is in quadrant 2 and therefore it should be a negative value, correct? You know the cost rule, correct? So tan 105 should be negative, and as we can see, we got the answer, which is minus 2 minus square root 3. Now let us see how do we solve question number 2. Show that sine alpha plus beta is, well, there is a typing error here. So let me rewrite the question. It is show that sine alpha plus beta plus sine alpha minus beta equals to 2 sine alpha cos beta. Is that okay? So that should have been the question. So we need to show that. And then part 2b is express 2 sine 8x cos 2x in the form sine a plus sine b. So we can write the sum of these angles as the product of as shown here. So let's work on this. So let me provide you with the solution of part A first, and then we'll look into B, right? So we'll do solution of question 2A. So we have sine alpha plus beta is what? That is equal to sine alpha cos beta plus cos alpha sine beta, correct? What is sine of alpha minus beta? That is sine alpha cos beta minus cos alpha sine beta, correct? Now, if I add them, what do I get? So let me add them. Adding the two, we get sine alpha plus beta plus sine alpha minus beta equals 2. So as you can see, the terms cos alpha sine beta cancel, right? Because they are plus and minus. And we get 2 times sine alpha cos beta as asked for, correct? So that is how we do it, right? So this implies that sine alpha plus beta plus sine alpha minus beta is 2 times sine alpha cos beta. Is that correct? So we have done this part, and now let us look into the solution of question 2b, right? So I'll squeeze that in here. I hope this derivation is simple and straightforward. So we have actually proven the formula. As you can see here, sine alpha plus beta is given to us, and sine alpha minus beta is also known to us. If you add them both of them together, you get your formula, right? Now let's do part B. We're done with A. 2 sine, let me rewrite this. We have 2 sine 8x cos 2x, correct? So applying this particular formula, where you can see that alpha is 8x and beta is 2x, right? So we can say this is equal to sine of sum of these two, which is 8x plus 2x, plus sine of 8x minus 2x. You get the idea. So that is sine of 10x plus sine of 6x. So that is what the result is. So we can now write it in the form of sine A plus sine B, and clearly what we get here is A equals to tan x and B equals to 6x. You get the idea. So that is how we could do part B of question number 2. So sorry for this typing error. However, I hope you find it interesting and useful to see how do we derive a new formula and then apply it to solve a question. Correct? Question number 3 here is solve the equation 2 sine x plus pi by 3 equals to sine x plus square root 3 cos x. So we can again apply the cosine function and sine function formula. So we have the formula which we are going to apply is this: sine A plus B is basically equal to sine A cos B plus cos A sine B. To find the exact angle for pi by 3, we can use our special triangle, right? Which is, if it is pi by 3, the sides are 1, 2, and square root 3, right? Correct. So we can use this triangle and we know sine and cosine value from this particular triangle. So we can write 2 times sine of x plus pi by 3 as equal to 2 times, let me put it outside the bracket, sine x cos of pi by 3 plus cos x sine of pi by 3. And that is equal to 2 times sine x. Cos pi by 3 is half, and then we have cos x sine pi by 3 square root 3 over 2. Multiplying both by 2, that is distributive property, right? What do you get? Well, we get sine x plus square root 3 cos x, and that's what we need, right? So that is how you show that this is absolutely correct. Now let's look into part B, which is show that sine of x plus square pi by 3 is cos of x plus pi by 6 can be written in this particular form. So now to show that, we know the left side, we have already done that, is equal to what? We just show that 2 sine x plus pi by 3, as done in part A, is sine x plus square root 3 cos x, right? So we can write this as sine x plus square root 3 cos x. How? We can do the same thing as we did last time for the left hand side, for the right. Cos A plus B formula, right? So we have cos x cos of pi by 6 minus sine x sine of pi by 6, right? So this part, first one, we actually got it from question 3a, right? And then this part we are now trying to Fine. We'll again use the right angle triangle, which is a special triangle, 1, 2, square root 3. The angle pi by 6 this time is that angle. So we can say that sine x plus square root 3 cos x is equal to cos x. Cos pi by 6 is square root 3 over 2, right? Minus sine x, and sine pi by 6 is half. Multiplying by 2 on both the sides, what do we get? We can say this is 2 sine x plus 2 square root 3 cos x equals to square root 3 cos x minus sine x. Now bringing cos and sine together, we have to get 3 tan x equals to square root 3. So we can bring all the terms together. Bringing everything on the left hand side, we get 2 sine x plus sine x plus 2 square root 3 cos x minus square root 3 cos x equals to 0. And now we can divide both sides by cos x. So if I divide both sides by cos x, 2 sine x plus x is 3, right? So we get what? We get 3 sine x. And here we have 2 square root 3 cos x minus square root 3 cos x gives us square root 3 cos x, right? Two of them take one over them away, square root 3 cos x equals to 0. So we are now dividing both sides by cos x. And so what do we get? We get a result which is 3 tan x plus square root 3 equals to 0. Does it make sense to you? So we could simplify this and get the result. Now that leads to the next part, which is we need to solve equation 2 sine x plus pi by 3 equals to cos of x plus pi by 6, where x is between 0 to 2 pi. So basically we know this is equal to 3 tan x plus square root 3 equals to 0. So we now have to solve the equation, which is 3 tan x plus square root 3 equals to 0. So that can be written as tan x equals to minus square root 3 divided by 3, right? Which is minus 1 over square root 3. Now that means tan is negative, and within the given domain, which is from 0 to 2 pi, we are looking for solutions in quadrant 3 and 4, right? We use the cost rule. So tan is negative. And from our special triangles, we know the value of tan, which will be 1 over square root 3. So 1, 2, square root 3. So 1 over square root 3 is for this angle, which is pi by 6, the opposite side being 1. So we know that the related acute angle in this case is pi by 6, right? So from here, within this domain of 0 to 2 pi, we get two solutions. And these two solutions are which one? Both negative means we're looking into quadrant 2 and quadrant 4 with related acute angle of pi by 6. Correct? So we know that for tan x equals to minus 1 over square root 3, we have a solution in quadrant 2 and in quadrant 4. The angle being pi minus pi by 6 and 2 pi minus pi by 6, and that gives you 6 minus 1, which is 5 pi by 6, and 12 minus 1, 11 pi by 6. Is that clear to you? Perfect. So since the related acute angle is pi by 6, correct? We know tan pi by 6 is basically equal to 1 over square root 3. So the related acute angle is pi by 6. Solution being in quadrant 2 and 4, it will be pi minus pi by 6 and 2 pi minus pi by 6. So that is how we can find the solution. So I hope this solution is absolutely clear. Now let's take up the last question, which is question number 4. Part A is, show that the equation cos x plus 5 pi by 6 equals to sin x can be written in the form cos x plus square root 3 sin x equals to 0. Very interesting question. I would like you to pause the video and answer this question. So let's work on this, which is cos of x plus 5 pi by 6 equals to sin x. Now expanding cos x plus 5 pi by 6, what do we get? We get cos x cos 5 pi by 6 minus sin x sine of 5 pi by 6, and that should be equal to sin x. Let's find the value of cos x cos 5 pi by 6x. So in this particular triangle, which is special triangle, the angle pi by 6 being as shown, we know that 5 pi by 6 really mean that we are working in quadrant 2, where the angle 5 pi by 6 is right there, correct? And you know the cost rule, that means cosine is negative and sine is positive. So we know that cos 5 pi by 6 is basically equals to minus of square root 3 over 2, and sine 5 pi by 6 is basically equal to plus half. So let's substitute these values now. We get cos x minus square root 3 over 2 minus sin x times half equals to sin x. Is that clear to you? Now, we can multiply everything by 2. We really need cos x, right? Plus square root 3 sin x equals to 0. That is what we need. Bring all the terms together, multiply by 2. So we get minus square root 3 cos x, and we can write this as minus sin x times 2. I'm multiplying everything by 2 first. So that cancels. So we can write this as only sin x equals to 2 sin x. You get the idea. So what we did here is times 2 each side, right? So times 2. Now bringing them together, we get 2 sin x plus sin x plus square root 3 cos x equals to 0. But we want only cos x, so what we can do is we can now divide by square root 3. So let us divide all the terms by square root 3, right? And then see what do we get. So at present, 2 plus 1 is 3. So we have 3 sin x plus square root 3 cos x, correct? Equals to 0. Now if I divide by square root 3, I get what? I get 3 over square root 3 sin x plus square root 3 over square root 3 cos x equals to 0. And that gives you square root 3 sine x plus cos x equals to 0. Correct? And so we get that this expression is equal to cos x plus square root 3 sine x equals to 0. Is that clear to you? So that is how we can get this particular expression. Now let's look into the last part of it, and that is, once we have shown this, in that case, we need to now solve this given equation within the domain 0 to 2 pi. Correct? So we can now write the expression given to us as cos x plus square root 3 sine x equals to 0. And we can solve it within 0 to 2 pi. So we'll work on cos x plus square root 3 sine x equals to 0. Now if I divide everything by cos, what do I get? So I get cos x over cos x plus square root 3 sine x over cos x equals to 0. And that is 1 plus square root 3 tan x equals to 0, or tan x equals to minus 1 over square root 3. Since tan x is 1 over square root 3, looking into our special triangle, which is right there for you, 1, 2 square root 3, opposite over hypotenuse, so it is pi by 6. So we know that the acute angle is pi by 6. Since we need negative answer, our solution lies in quadrant 2 and in quadrant 4, where the principal angle is what? Well, the principal angle is in quadrant 2 will be 5 pi by 6, and in quadrant 4 will be 11 pi by 6, correct? So now we get the value between 0 to 2 pi. So we know tan of alpha equals to 1 over square root 3 gives related acute angle as pi by 6. And therefore, when we say tan x equals to minus 1 over square root 3, we know x is equal to pi minus pi by 6, or it is 2 pi minus pi by 6, and that is, we have 5 pi by 6 and 11 pi by 6. Is that clear to you? So that is how we are going to answer this particular question. So I hope these steps are absolutely clear. I'd like you to draw the attention on few other questions which you could do at the end of this assignment. Most important is derive the formula, right? So as an assignment, you can take derivation of formulae. These are important set of formulae. And then we have sum to product formula. So you can practice for your test, try to solve these questions. I hope that makes sense. You can also look into my videos for the solution. Thanks for your time and all the best.